So, welcome everybody to Functional Design Europe. Glad to see you all here. This is the first day, of course. You might have noticed that yesterday and the day before that, there was another conference at this very venue, and it was called, you can see it up there, Domain-Driven Design Europe, and they even stole the logo design for some reason. So anyway, so they're kind of a tiny niche faction inside software development. So I figured it might be interesting for you to learn what this domain-driven design thing is about. And so I invited one of their spokespersons. This is Henning Schwentner.
First thing maybe I would like to know is, are there some functional programmers here?
Well, everybody, right?
Yeah,
everybody?
Yeah, okay.
See? Everybody.
Very good.
Right.
Okay, yeah, what I usually would do is first not think about programming at all, not functional or
You're not thinking about programming?
Object-oriented or whatever. What I would do first is think about the problem. Actually, I would want to go a bit deeper to understand the process, what's actually happening here in our example.
Okay.
So we can then see how we can derive a domain model from that.
Okay,
right?
so you want to gain better understanding, so you're just going to think?
Yeah.
Okay.
I want to think, yes, but I also want to talk.
Okay.
Yeah.
Think and talk.
Think and talk. And
okay.
I want you to tell me a little story, because usually what I would do was I would invite some real domain experts, so people that are really doing the work here, and then I would interview them. And
I
learn
know
about
everything about the domain, right?
Okay, oh, that's
so
good.
You don't need a domain expert.
Okay, so
right?
you are my domain expert.
Yeah,
then.
I'm your domain expert,
okay.
right? In case that wasn't clear. Okay, Henning? Mm-hmm.
Okay, then I'm going to use a method or tool that's called domain storytelling. The idea is that I want you to tell me a little story, and then I see how that story goes on.
Okay.
And this story is a domain story, so it's not a fairy tale that I want to hear.
Okay.
It's some real life stuff. So let's start with an overview. So you can see here, I already gave that story a name. It's AA key number 1.
So you're talking about a story, but there's a blank screen here.
Yeah, true. Because we haven't started with a story, right?
Okay.
So you are going to tell me that story, and I want it to be an overview story. I don't want to go into all the details now.
Sure. Okay.
Maybe we do that later.
Whatever.
Okay. So you said there's a shopper, right?
Yeah. I mean, like a customer enters the store, that's the shopper. Okay.
Okay. So that the customer.
Your story, it's like pictures?
Right. So
while
you are telling that story, I want to draw a diagram out of that story.
Like it's a children's book.
Well, yeah, kind of.
Sure. Pictures, whatever.
Yeah, the point is, I'm maybe not as super smart as you are, so I want to show you what I have understood, if I got you right.
Okay, sure. Draw pictures to understand.
Okay, so we have this shopper here.
Okay.
And what do they do?
Well, shopper enters the store, right? And looks like through our great shelves with articles in it, right?
Okay.
There's all kinds of items.
So there's articles and there's shelves and those are the things. What's happening? What does the shopper do with the shelf and the
look
article?
At all that stuff, right? It's so the store is designed so that you will always see articles in your, field of vision.
Okay. So if I get you right, then the first thing that the shopper is doing, that they are looking for an article or searching an article, right?
Yeah.
Okay.
Right, and the genius thing is, right, they might be looking for a piece of furniture they already know about, but then they walk through a bunch of other stuff that, piques their interest.
Okay, so the first step that I write down then is the shopper looks for an article in the shelf.
Okay.
And then what happens next?
Well, then the shopper goes, oh, that, candle diffuser looks great. I want to have that, right?
Okay.
And that sofa also looks great. I'm going to have that. And they put it in their shopping cart.
Okay, so there's another thing here. If I get you right, this shopping cart, right?
Yeah, shopping cart.
Okay, so the shopper, you said the shopper puts the article into the shopping cart.
Yeah.
Okay, and then what?
Well, and then, once they've selected, they've put all the articles that they want in their shopping cart, they go to checkout.
Okay, they go to checkout. Yeah. And what do they do at the checkout?
Well, they mainly pay for the articles that they have, right?
Okay.
And they tell them where to ship them, right? That's the most important part.
Okay, they tell them. So there are people
Yeah, yeah. This
working
would
at the
be
shop.
like in a regular store. This would be like a cashier or something, right?
Okay, so there's a cashier here.
There's a cashier, yeah,
Okay.
and
with the cashier, the shopper pays the card. Is that right?
they pay for the cart. Yeah.
Yeah. Okay. And you said something else there. They pay for the card and what?
They pay for the cart, and they they tell the cashier where they want things shipped.
Okay.
Okay.
And where do they want it shipped? How is that called?
Like it says shipping address.
A shipping
like
address.
an address. You've never heard
Okay.
of addresses before?
Yeah, actually I did, but not from you so far.
Okay.
So
I mean, it could
that's
be.
what I was asking.
It could, right? Yeah. Well, so it could be the address of somebody's home, right? Or it could be the address of one of those pack station things.
Okay.
Okay.
So the shopper tells the shipping address, shipment address, or shipping address.
Just shipping, whatever, shipping address.
Okay.
It's like you're doing pictures, but you're obsessing about words.
True. Yeah.
Okay.
That's basically what we're doing in DDD.
Okay. We're just gonna all listen to Henning, okay? Whatever he's doing.
Okay, so the shopper.
Hopefully, it's gonna make sense in the end.
Yeah. Well, it depends on the domain expert if it makes sense in the end.
Don't you worry about that. You worry about your pictures, Henning.
Okay. And about the language.
Mhm.
Okay, so you said the shopper tells the shipping address to the cashier, and you said the shipping address can be a home address or a pack station.
Yeah.
Okay. So that's one of these crazy things that you have over in Germany, right?
Yeah. Yep. So Henning,
Okay.
seriously, how long is this going to take? Because I would already be writing code at this point.
Yeah. Okay. Maybe we talk about that later.
Okay.
Okay.
Digital transformation, pictures. Mm-hmm.
Yeah, I'm using a digital tool for drawing these pictures.
Okay.
Okay, so the shopper tells the shipping address to the cashier, and then
But
what?
seriously, Henning, I was there yesterday, and it seems these folks like they put like actual like physical post-it notes on the wall, right?
Yeah, we actually do. Yeah.
You do that?
Yeah.
Okay.
Even in different colors,
Okay. Well, whatever.
and they have a meaning.
Okay.
Okay, so the shopper tells the shipping address to the cashier, and then what?
Well,
What's done with?
I mean, then the shopper just leaves, right? Because they're, the furniture, it's usually too large to put in their own car.
Okay.
Or if they arrive by public transport. So they're having that delivered, they're having their cart delivered to whatever address they specify.
Okay, who does this delivery?
Well,
Is that the cashier?
No, it's not the cashier. It's like a delivery agent. Okay.
Okay, so there's a delivery agent here. And what does the delivery agent do?
Well, picks up, they always come in at night, just, when the store closes, the delivery agent comes, right? And there's this whole room full of shopping carts, and they put a bunch of shopping carts in their truck.
Okay, the
And
whole
deliver
shopping
it.
cart. Okay, so they picks up the cart from the cashier, and you said that's at night. Is that important for the story?
I mean, they could pick it up at any time, right? But for some reason, they always do it when the store closes. So I don't think it's important.
Okay, and then the delivery agent has picked up the cart, and then what?
Well, then delivers the cart, right?
Okay.
To the shopper guy there.
Okay, so I assume to the shipping address, right?
Yeah.
That's
Yeah. Oh, yeah. You're right. Yeah. Well, shopper might not be home.
okay. So the shipping address.
Mm-hmm.
So the delivery agent delivers the cart to the shipping address.
Mm-hmm.
And I think that's the shipping address of the shopper, right?
Okay. Yeah.
Okay. And is that it on a course grade?
Yeah, that's it. Can we start writing code
thing?
now, please?
There's one more thing we have to do, and then we can start writing code. Yeah.
Yeah. Maybe I'll do a little bit so we actually make some progress today.
Okay. You mean you want to, with your dirty hands, you want to touch my keyboard? Yeah. Okay. So
enlighten your keyboard.
Yeah.
Right?
Enlighten
Grace
my keyboard.
your keyboard.
Okay. So what I usually would do before writing code, or I would say what generally DDD people would do before writing code, is what we call strategic design.
Wow. Okay.
So we first would want to know, well, where are boundaries? And what we want to do is, well, take this big thing that we have here and split that into parts. So we can build our software system also out of parts, right?
Okay. Well, why don't you just build the parts? I mean, you haven't even built parts. How are you going to split them?
Yeah, that's the point. It's called domain-driven design because we want to understand the domain and we want to let the design of our parts be driven by the domain. So we want to see.
That's what we do too, right? Just so you know, Henning. Okay. So but we'll get to that later, right? You do your boundaries.
Nice. So for example, I would say we have a boundary here. We have a box here, if you like. So there's step number 1 where the shopper looks for articles in the shelf. I think that's the article search.
Okay. Yeah, that makes sense.
So, and when you look at this as a domain expert, do you see other boxes here, other subdomains?
Well, then it's just like shopper puts something into a shopping cart, right? Actually does the shopping.
Okay, that's the shopping. Okay.
Okay.
And then you said something about checkout earlier?
Yeah. Then they go to checkout, right?
Okay, and that's the steps 3 and 4? Do I get that right?
Well, if you can show, I see 3 and 4. Could you scroll up so I could actually see that?
Yeah.
Okay, yeah, that would be 3 and 4.
Okay. So sorry, the tool is not doing what I wanted to do.
That's why you're using post-its, I guess, usually.
True.
Okay.
That is exactly the reason. Because they always do what you want to do. And so we have the checkout here, and then these steps 5 and 6.
Yes.
Do they belong together? Yeah, right?
Yeah.
What's that? That box?
Delivery?
Delivery.
Maybe.
Okay. That sounds reasonable. So, and what you see now is we have 4 boxes here. And what we would do in DDD is we would say, well, we are building a modular system made out of 4 modules. We call them bounded context.
Okay. We just call them modules.
Okay.
But okay. Bounded context.
Yeah, you see, because there's a boundary around them. Right?
Yeah. No, I get that. It's fine.
Okay. So now we have these bounded contexts. So we have understood our process.
Okay.
Or part of the process. We've found these subdomains. We know how to build our modules there. And well, what we typically do next is that we get
write code, right? You're going to write code.
Yeah, I think we need to gain some more knowledge to really write code. So you talked about this can be a home address or a pack station. You said there are different cases there. Yeah. So that's why I would like to zoom into this box delivery here, into that bounded context delivery here. So I understand there are basically 2 cases. Yeah. And that is, let's put them into their own pictures because those are own stories. Let's start with AEKI number 2, the delivery directly to home, because if I got you right, that's the standard case. Yeah. Normally, the delivery guy brings the furniture to your home.
Yeah, well, right? Not everybody has a pack station, right?
Okay.
Right, and of course, to a home address, you can deliver both lifestyle items and furniture, so it's more flexible.
Yeah. Okay, so we have the delivery agent here, and we have the shopper, of course, and so what's happening? The delivery agent, what do they do?
Well, delivery agent will, I guess the best case is when the shopper is home, right? And so the delivery agent will just give the contents of the shopping cart to the shopper.
Okay. The contents of the shopping cart. So you say the best case is the shopper's home.
Well, you said you want like the best case.
Right? Yeah, I want the best case. Right. So I write an assumption here. The shopper is home.
You mean for every case you're going to write like another picture?
Nah, not for every case. Only for the interesting ones.
Oh, okay. Well, thank goodness. The interesting cases.
The shopper is home. The shopper is me. So you say the delivery agent delivers the contents of the shopping cart, and the shopping cart contents, well, those are the articles, right?
That's right.
And they deliver it to the home of the shopper, or
That's
the home address, you said, right?
Yeah. Okay, and then, you know, whatever, the shopper signs like a receipt, you know, delivery agent goes on to the next shopper,
Okay.
to the next shopper's home address.
Okay. So then I put this thing with a receipt here. The shopper signs. Oh my God. For the delivery agent. Okay, so this is the case, delivery directly to home.
Yeah.
And then, Mike, you told us there's another case, this delivery
Yeah.
to a pack station.
Yeah. Oh,
Okay.
another picture.
Another picture, yeah.
Okay.
How does that work out?
Well, that's very simple. So delivery agent just delivers it to a pack station instead of a home address.
Okay. So delivers it, I think by it you mean the article, right? Yeah. Article to a pack station.
Yeah.
Okay. And then?
And then the pack station writes an email to Aiki confirming delivery.
Okay. To Aiki or to the customer, to the shopper?
Well, Aiki then will forward it. So I guess for the purpose of this picture, the email directly goes to the customer.
Okay. So I use the email symbol here.
Good point.
Right. Email, how is that called, this email?
Delivery confirmation.
Okay, delivery confirmation to the shopper, and then?
That's it, right?
That's it?
That's it.
So the shopper
might or might not pick it up, right? They might have died in the meantime, and it just stays in there.
Okay, let's stay with the happy path.
Okay.
They have not died.
Okay, well then the shopper goes to the pack station and removes the article. Okay. And does whatever they do with those articles, right?
Okay.
Set the diffuser on fire.
Okay. So you said remove, picks up. What is it that the shopper does?
I don't know. Picks up, I guess.
Mr. Super Domain Expert?
Yeah.
Okay.
Well, it's language, right? There's synonyms.
Okay. Okay, thank you. So now we see these different cases here. We have this delivery directly to home and delivery to pack station.
Yeah. And then, Henning, I think everybody needs to take a break here, and we need to write some code.
Yeah. Okay. Okay.
Because otherwise, we're just going to die, everybody in this room, from all that thinking. Okay.
Okay.
So,
I thought from all that talking.
Just so we all are on the same page and you learn how this works, right? So here's, I already said that, right? In functional programming, you know, it's a module, right? So this is Haskell. Everybody here knows Haskell, right? Could you please all raise your hands? See everybody, Henning, okay? Knowing right? There's a module called cart, right? Because we're all about shopping carts here. We're just gonna take like a little section of this picture, right? And we could say, you know, in the moment when the domain expert said, well, we're going to do, you know, an article, it might be a lifestyle article, or it could be a piece of furniture. We can already write code, right? We don't have to go through pictures. So here's furniture. And similarly, so if you, well, Henning, for you, right, data means we're defining a data type.
Okay, thank you.
Mathematics. And then there's this vertical bar, means or, right? So you read this by saying article is lifestyle, is a lifestyle item, or it's a furniture. Okay. And then, of course, we have this thing called shipping address, right? And also just from talking, right, from just listening, right, not drawing pictures, we can infer that there's either a home address or there is, what was the other thing? That there was a pack station, right? And also, what we didn't get from your picture quite was that, I mean, you saw the happy path, right? But the unhappy path is kind of, you go with your furniture to checkout, and then you discover that you've specified a pack station as your shipping address, right? You know, you might have written it on a piece of paper, given it to the cashier, and the cashier goes, oh no, we don't do this. And then you have to make changes, Okay, does that make sense?
Yeah.
Did I get
Yeah,
that
you,
from
you
listening?
were the one who
So
said
let
we
me-
don't
So
want to
there's
look at
kind of
other
this thing
cases.
where the shipping address might not be like the final shipping address. So I'm just going to write like a data type. I'm going to call it tentative shipping address maybe, so it could be like the shipping address has not been specified yet. You just go there to the cashier with an empty mind or with a blank mind. So you might say no shipping address, or you might say, well, it might turn out that the shipping address is valid. Right, and ideally, I'm thinking it would be great if we could see that, like, while at the moment that we've specified the shipping address, if it's valid or not. So we can just put that in here, and it might be invalid. And in this case, we kind of don't want to lose the shipping address, so we still want to keep track of what it is. But there might be a reason for an invalid shipping address like this. Right? We haven't defined that yet, and right now, but we can do that here. And right now, the only thing is there's like no furniture to pack station, right? And so we now have a little data model there, and we can just do that from listening. Okay?
Yeah.
So
Yeah, and I like that we have a little data model here. I think it's not only a data model; it's also a domain model, and there's where, for me, a problem comes up here. Article, shipping address. Those are words that we learned from our domain expert. That's something that we learned in our collaborative modeling session. But tentative shipping address, valid, invalid, those are things that you made up.
absolutely,
And not you as a domain expert, but you as a programmer. And I don't think that's the best way to go here.
Okay.
So when we want to change the process, change the domain, what we're doing here, then I think it's a good idea to do that with feedback from our users, with feedback from our domain experts.
Well, we would do that too, right? We would, I mean, this is going to very quickly turn into executable code that we can also discuss with the client.
Yeah. Yeah, I think Haskell is the perfect notation to discuss it with clients.
Yeah.
No.
Everybody's laughing because they go, yeah,
yeah, of course. Yeah.
no.
What I actually would do is, when we're thinking about these domain stories that we saw, but it's true for other methods as well, we started with looking at the as-is situation, and here we are moving on to a to-be situation. So how is the situation now? How will it be with the new system?
But we want to get from the as-is to the to-be, right? As quickly as possible. And you're like doodling pictures.
Yeah.
Right.
Typically, the pictures will help you get there quickly because they are a means of communication with your users, with your domain experts. And then we're not going to do this now. It's okay, Mike. We've drawn enough
but
pictures.
But you are going to write code at some point.
Yeah, you asked me to, so maybe I'm going to do that now.
Is that like in your job description, code only on special request? Okay.
No.
Until that, we only draw pictures?
No. Unfortunately, it's the other way around. Most of my clients don't pay me for writing code anymore, but for drawing pictures.
Okay.
That's kind of sad, actually.
Yeah, that sounds very sad, Henning. Very sad. Okay. But here you get the opportunity.
Thank you.
How will you do this?
Yeah, thank you. Functional programming.
Yeah.
What was that called? Functional Programming Europe or what?
Yeah. Functional Design Europe.
Okay.
Yeah.
So what I see as a difference, what you did was write productive code first. What I would do would be to write test code first. So coming from our stories here, where we see.
But you don't have anything to test yet, Henning.
Yeah, that's the point.
Okay.
But what I have, or what we have, is domain knowledge, and we've even learned about different cases here. Another method that might be used here instead of domain stories might be example mapping, where we find different examples for this here.
Okay.
And then that's something that comes from BDD, behavior-driven development.
More Ds?
More Ds, and
you realize it is Friday afternoon, Henning.
I do.
Okay.
Yeah, and so I give you another abbreviation with Ds.
Okay.
That's TDD. That's what we're going to do now. Test-driven development. So we look at these two cases and we write test code for them.
Okay.
And I've prepared something, these two test cases here, in a maybe not as beautiful language as Haskell, but a language that's actually used in production.
Okay.
So
This is like Java, right?
yeah, this
okay.
exactly. This is Java.
Okay.
At least it's modern Java. But some Java developers here as well.
Okay. Yeah.
I think
like
those are
3.
more hands,
Huh?
right? Who's a Java and Haskell developer? No hands actually.
Yeah.
Right? Oh, that's interesting. Okay, so I said BDD, TDD, test-driven development. BDD people, they like this given, when, then thingy.
Okay.
So they
And that's
say,
why you have to type these long words.
yeah, you don't
You
have
must
to.
be
But
very tired.
yeah.
Okay.
That's why I prepared them, and I'm not writing them now.
Okay.
So they have this idea of given, when, then. So they say, well, if the world is like this, and when we do the thing that we want to test, then we can check some situation that comes out of it. Okay, and you see I have 2 test cases here. This given a card when putting a lifestyle article into it, then delivery address can be Packstation. And then the other test case is given a card when putting a furniture article in them, then delivery address cannot be Packstation. That's what I got from what you told me, right?
Okay. At that point, you got to take a break. Okay.
Maybe.
Okay. And then?
And oh, sorry. Yeah, here we go. So here we can see the implementation of that test case. So given, when, then again. So given a new card, that's something that
what is that card class? Where is it, Henning?
It's not, you can see this is red.
Okay.
Because it's not there yet.
It's not there yet.
Yeah. That's this whole idea of test-driven development, of writing the test codes first, and then the test code will carve us out the.
So it's like you keep waiting. I sure hope there's going to be code.
Yeah.
Okay.
Yeah, I think we only have 20 minutes left, so maybe.
Yeah, step it up, Henning.
Okay. Okay, so then we have this new card. Maybe if you will not interrupt me, then I can. Okay, so we have this new card here. And when on this card under test, we put a new article, then we can assert something. And you see this new article, it gets an article name and an article category, the lifestyle here. And then we test that this card under test is deliverable to an address type, home address. And we assert that this is true, right? Okay, this is test case number 1. And here we have test case number 2, which looks a bit similar. We have a new card and we put another article into it, a leather sofa, not white candles. This is furniture.
Okay.
And then is deliverable to Packstation will be false.
Okay.
That's what we assume. So as you said, there's a lot of red stuff here. So let's use our IDE to generate that code. So we can just say, generate a class with the name card here. And as we say in DDD, this is an entity because it has an identity. And Java programmers, be aware, this is JMolecule's entity. So DDD entity, not a database entity.
Okay.
Okay, so now we have a card. It's not red anymore. You see that here, right? And then we do the same thing here for the article name. We use a record here.
Okay.
Because
I guess most of you don't know Java. This is something that was imported from functional programming. So they're now catching up. Of course, we've had this in Haskell since about 1991.
Of course.
Who was born then? Okay, 3 people.
Okay, so we use a record here because the article name, that's what we call a value object in DDD.
Oh, so you could put value object or entity there? How do you know which one is which?
It's a question of identity.
What is that?
That's the philosophical answer. And the other answer is maybe if it's a thing, if you can touch it, then it's an entity. If it's a property of a thing, something to describe a thing, then it's a value object.
Okay.
Okay, so now we have a card, which is an entity, a value object, article name, and we need some other stuff here as well. Of course, here the article category that will also be a type here. And is that a value object or an entity? Who's still awake? Okay. Yeah, I agree. I think that's a value object, and I would take an enum here because we can see here this category can be either a lifestyle thing or a furniture thing. And you can see here it generates us here constants in this type. Why is this? Lifestyle. Gesundheit. So now we have these values here, and then we have this article, and we can also generate that and say, well, that's again a value, that's again an entity. So article name, and article category, okay. This article also has an identity, so this name here is, as a first idea, is the idea of this. Maybe we will do later something else with it. So now we can finally go back to our card and say, well, we create a method put in that, where we can put an article into the cart. Yeah, which will not always be white candles, but an article here. And then we need the home address, of course, and that's again an enum, and also a value object. And I think, Mike, you get the idea, right?
Yeah, I get the idea. So maybe you can just get rid of the red, and I can. This is going to take forever, right? And you haven't even implemented functionality yet, right?
True.
Okay.
So, and here this is deliverable too. Well, we need that as well.
Okay.
So we say, yeah, well, it's a Boolean coming back here, and you see the IDE knows a lot of stuff about this address type here. Okay, and let's start with return false.
Return false? It's never deliverable?
It's never deliverable. But maybe it may not be deliverable, but at least now it's compilable.
Okay.
And
oh, wow. Compilable. I compiled 20 minutes ago, Henning.
Okay. And so now we can run this here. Oh, sorry, no, we can run this. Oh my God, we can run this. And see, well, there's one test case.
Of course there's a test failed. You didn't implement anything.
Exactly.
Yeah, Henning, go.
And actually, that's what we want to have.
Yeah. So
okay.
I'm gonna write some more. So I'm just gonna do what you did, but in 2 minutes.
Okay.
Right? So yeah, thank you. So what was it called? Is just from listening, I heard that really, if a shipping address works or not, really depends on the article. So really, we want a function. Let me scroll up. We can scroll up, right? And so we want like a shipping address. We want an article. And now here's this thing that you said I made up, right? This tentative shipping address is now provides me a rich data type to talk about, not just is it deliverable or not, but also why it might be undeliverable. So the data type that I have, that I did from not listening to the domain expert, I guess, now allows me to express something that is kind of a little Boolean blind in your software, right? So let's see, right? If and pack station, I'm just going to implement this, right? Furniture, that gives me an invalid shipping address. So that gives me this, right? And everything else, gives me a valid shipping address. So done, right? And so now I actually have a piece of functionality. This is a complete specification. I can run it on all the cases and test it and discuss it with the clients and so on, right? And also looking at this, right? I know you're going to complain about this, but looking at this data type here, the tentative shipping address data type, it really seems an obvious candidate for abstraction because it's like a container, right? And if I look at this from the viewpoint of functional programming, as everybody else does in this room, right? They will notice that this is kind of the optional pattern that I believe they've imported to Java from functional programming a few years ago. So we could just eliminate this case and instead stick a maybe in the shopping cart there, or an optional in the shopping cart. And then this is just a container for a shipping address. So we can kind of shorten this a little bit. We can just remove all the concrete mention of shipping address here, just stick an A here.
We can remove all the concrete, right?
We can remove all the concrete, right? And so again, let's get rid of the shipping address here. Let's get rid of the shipping address here. Your auto repeat is kind of slow. And stick that here. And then we can see that whatever the reason for something to be invalid, it doesn't have to, it also refers to a shipping address. So we should abstract over that as well. So do it like this, right? And so these are now generics, for those 3 folks that only knew Java in the audience. And now, if we have something like this, if we have a generic parameter, we immediately wonder if it's what's called a functor, right? If it has like a map-like function, and sure enough, if we go like tentative, I'm sorry, I said functor, so we're going to write that down. We can codify that and say, well, so here's fmap. Oops, I'm sorry, fmap of a valid a, right? That's valid of f of a, and fmap f of invalid a, and some reason is still invalid. We don't want it to become valid suddenly. And do it like this, right? And then obviously, if we're going to think about, well, maybe first fix this piece of code here. So now a tentative shipping address is now just a tentative, and then we use that reason data type and shipping address and replace the constructors down here. So I don't need the IDE to write my code for me. I can just do that myself.
That's impressive.
Well, so there we go. Everything type checks, I think. And of course,
I believe
once
Mike,
that we have a functor,
Mike, stop
right,
it, stop it.
We're going to look if it's also an applicative, right? Which is the next higher level abstraction.
Yeah.
Oops. I should maybe have the IDE write that for me.
Yeah, I think the IDE that you're usually using is Emacs, right?
Of course it is. Yeah.
I'm more of a VI type of guy. But
yeah, you would, Henning, you would.
Quick show of hands. Who's for Emacs? Who's for VI?
So
anyway, there you go.
Anyway, so here, if we have 2 valids, we're combining this with this TIE fighter operator of the applicative functor. That's going to be a valid of f of a. And if we have 2 invalids, and now it's going to get, I think it's going to get interesting, right? We have reason 1.
Yeah, Mike, before we're coming to the interesting part.
Well, we're already beyond your code. This already, the code that you started writing has started working long ago here. Okay, so I get like 2 minutes, right? And here we can see that, well, in order to combine these 2 invalids, we need to also combine the reasons that are in there. So this gives us domain insight. And the domain insight, well, we might turn this into a monoid, but we'll just do it really simply and stick a list in here. And do it like this. So that works. And then we can combine these 2 things, right? And this will, if we actually continued writing code about the shopping carts, we would see that we would get really, really nice reporting of any problems there are in the shopping cart. Okay,
Mike, this is all nice functional programming stuff, and we have a tentative now and a functor, applicative, a TIE fighter operator.
Yeah, TIE fighter operator
stuff. Probably the next thing you're going to say is, let's build a monad.
Yeah, of course. I'm sorry, I forgot about that.
No, sorry, but we don't have the time for that.
Yeah, okay.
So I think it's nice to have these functional programming terms, but what do they have to do with the domain stuff that we were talking about?
Well, they give us insights into our domain because we're using concepts from mathematics, which is what humanity used for domain modeling before there were computers, right? Before there were all these Ds.
Okay.
Right.
They're talking about the Ds. I see a lot of Fs and As here.
Yeah.
So maybe if we would want to do domain modeling like this, maybe we would want to have some more domain language words here, right?
Yeah,
you heard about this word ubiquitous language, maybe.
Okay. Yeah, I guess we should talk about that. So do we switch here? Does that work? Does that work? Oh, it actually almost works.
No, it actually didn't work, of course.
It did not work. Okay, so you said ubiquitous language. What is that? Can you explain that to the audience?
Yeah, maybe I explain it to you also.
Okay. Yeah.
So the ubiquitous language, that's this idea of understanding the domain terms,
Okay.
understanding the things in the domain and the actions that we're doing there, and then taking these terms and bring it into the program itself, on the UI of the program, but also on the code level.
Okay.
So that's why I have all these classes and methods and variables with domain names.
Okay.
And I think that's something that, well, you can do that in OO, and I think you can do that in FP very well.
Yeah.
And you should.
We probably should. Yeah, right. I certainly see a lot of Haskell code that has like one-letter identifiers, so
And that's very
it seems
concise.
that would be a useful idea.
Yeah. Okay.
So, but I should mention, right? It seems that you really had trouble with these names for abstract concepts, right? That occur in our domain that describe the words in your ubiquitous language, right? And we have a rich vocabulary of that in functional programming.
Yeah, and I think that's fine to have an abstract vocabulary. Nonetheless, this does not mean we can forget our concrete vocabulary.
No, absolutely not, right? We've described the concrete in terms of these abstractions.
So we have to know what a card is.
Yeah.
And we have to call it a card when it is a card.
No, that's fine, right? But we were thinking, the longer version of this talk, right? We were thinking about sort of emergent things, like, if a shopping cart is valid or not, and how to express these emergent concepts that are not in the original vocabulary of the domain experts. And that's, I feel some more work could be done there.
Yeah.
Okay,
sorry, I had to find my clicker here.
Okay.
So we can move on,
Yeah, let's move on.
Okay. So then there's this simplicity versus generality topic, what, has something to do with concrete versus abstract thing. And that is, which kind of simplicity is it that we're looking for? And, we've put these two quotes here. So what I would say, what we in the DDD community think is, when we build a piece of software, the first thing that we want it to be is usable. So our users actually can do something with that. And reuse may come after that. But that's not the first thing that we think about when we design software.
It sounds like you've had really traumatic experiences in your programmer's life.
Does it?
Well, I mean, we generally, as everybody knows here, right, is we tend to abstract fairly early because that gets us on a path towards particularly simple and universal concepts. And those tend to be the ones that are also easy to understand by the domain experts and the users.
Yeah, like monads.
Like a monad, actually, right? They don't have to be aware of the term for it, but it will give you a particular set of rules that you can follow when you're describing things that fit into its pattern.
Okay. Good. And yeah, then we see there are different recipes maybe, or methods or tools, whatever you like to call them.
Yeah, that really struck me, right? You started by writing functions, right? Essentially, that's the thing that you put in the center of your test case. And that's, I guess, what the B in your behavioral driven design is. Whereas that should be what I'm doing, right, as the functional designer. And instead, we have this rich discipline of designing data, of doing data modeling for data. Right?
Okay, so maybe we should switch the names. Is that what you're saying? Right.
Maybe we should, yeah. I mean, of course, behavior is data also in functional design. And so eventually, I think we'll come together. But it was certainly a marked difference in approach to designing software that we found.
Okay.
So that one, I mean, you showed this difference between entities and value objects, and I can kind of follow your abstract reasoning that it's a thing or it's not a thing. But it seems that whenever we look at a concrete domain, we disagree on what the entities and what the value objects are. And I wonder really if the difference between them is really well defined. And of course, in functional design, the difference is not particularly important in our software design. And what really strikes me is that they seem to be technical terms, right? Value, object, entity. Sounds like they're not in your famous ubiquitous language and domain vocabulary.
No, true. Right. They're not words from the domain. Those are modeling words.
Okay.
It's another language. Yes. Okay. And
so modeling words in the sense that like monoid and functor is.
Yeah.
Right?
touché. Maybe like that. And also, also we can discuss about, are these names so well chosen? Value, object. Well, what is it? A value or an object?
Yeah.
But actually, we're using objects to behave like values. That's how this name came up. Yeah. Okay. Yeah, and then finally, we haven't talked about mutability, which obviously is something that OO programmers and FP programmers look at maybe from a different perspective here.
Yeah, absolutely. Yeah, I mean, of course, we don't worry about mutability. We just don't do it, right?
Yeah.
How come? Well, how come you're doing it? It seems like a stupid idea.
Yeah. I think the thing is, you're in this, you're in the clouds thinking about math, and well, we are thinking about real problems, and the real problems happen in the real world, and well, the real world, it changes all the time. It's mutating all the time.
Yeah, but you're making a mistake there, Henning, right? You think you're modeling the real world, but you are really modeling what's in your mind about the real world, right? We just put a slide in there, if you could advance, right? Oh, they got the wrong logo. Okay, now, here, right? We really model what our perception of reality is, and that perception is immutable, right? Who was there in the talk at 11 o'clock about learning languages? Your long-term memory, it stays, it does not mutate, right?
Yeah, I think that's the problem, that your memory doesn't mutate. So
anymore is what you're saying.
That's what you said. And maybe that's something that's different between us. I'm open to change, and you're not.
Maybe that's it. Yeah.
Okay.
So let's wrap up.
With that we come to a wrap up. Yeah, I think when I think about what's important to me when modeling a domain, then collaborative modeling here is number one. So it's important for me to get understanding together with our users, with our domain experts. I want to know what they do. I want to understand the problem first before I come up with a solution. And that solution might even be functional programming. That might even be the right tool to use here.
You'll come around to it.
Yeah, I'm open to change, I told you. And then strategic design and ubiquitous language are two things that are important to me or to us as a DDD community. So strategic design first, before the tactical design. We first want to see DDD and Impera, where can we split our big domain into smaller subdomains? And we want to know that because that helps us design our software architecture as well. And ubiquitous language, of course, we want to know the words that our domain experts are using, and we want to use them as well in our code. And then you already mentioned that BDD and TDD, we like to start with the behavior, so not with the data. We want to know the what before we implement the how. And that means starting with operation signatures. That means fields and things like that. Data comes later, absolutely.
Yeah, so I think that's where we come together. We also design function signatures before we implement them, but we interleave function design with a rich discipline in data modeling. That I haven't seen to that degree yet in the object-oriented community. But I hope what's come across is that Henning and I go through very different activities, right? So we're doing something called design recipes, which is something that has evolved completely differently from domain-driven design. We're using abstraction early. I think you're using abstraction late, or you're reluctant to use abstraction. And so there's a lot of work to be done to integrate these disciplines and to have them benefit from each other to the fullest extent that that's possible.
Okay.
So,
yeah, and with that, thank you for Friday in the afternoon staying with us with such a nerdy topic so long. Thank you.
Yeah. Thanks, Henning, for coming.